Hi, and welcome to the third of 4 videos, which is also the third of the 4 types of our partial fractional decomposition. So we've looked at what? First case, distinct linear factors. Second case, repeating linear factors. Third case, the denominator is irreducible and contains a quadratic. So it has an x squared term as one of its factors, but we can't factor the x squared term down. So it's not like x squared minus 1, which is a difference of squares, and we can split it up as x plus 1, x minus 1. It's just simply polynomial over the quotient polynomial. So ax plus b. And so this is how we're going to solve these. When we have that, we set it up as ax plus b, a linear equation over the quadratic ax squared plus bx plus c that won't reduce. And then we do our LCD process and do our comparison, etc. So let's look at an example. Let's find the partial fractional decomposition of 2x squared minus x plus 4 all over x to the third plus 4x. So this guy here will only what? We can only factor out an x. That gives us x squared plus 4. I have a difference of squares formula. I don't have a sum of squares formula, which means this one will not reduce anymore, irreducible, and it has a quadratic, an x squared term. So to break this apart, first let's deal with this x. It's a linear, it's distinct, so that gives me my a over x. Now I need to deal with the quadratic part. So that goes in the denominator, x squared plus 4. In the numerator, it gets what? It gets a linear, ax plus b. Well, I've already used a, so choose, and this is an important part, always choose different variables. If you do a1, a2, a3, a4, that's fine. If you do a, b, c, d, e, f, that's fine. Just don't repeat them. Don't put a over x and then put ax plus b, because now you have 2 a's, so later on when you're solving, you're not sure which a goes with what. So I'm going to call this bx plus c. So it's a linear. ax plus b, I'm just changing the variables bx plus c so that I don't get confused. So now, again, multiply by the LCD, x times x squared plus 4, x times x squared plus 4, x times x squared plus 4. So on this side, as before, I'm left with 2x squared minus x plus 4. This side, the denominator should always cancel out everything. If it doesn't, you don't have something written right. Here, the x pieces cancel out, so I get a times x squared plus 4. And here the x squared plus 4's cancel out, so I get plus x times bx plus c. So now, I'll head up over this way. When I multiply these through, I get ax squared plus 4a, and over here I get bx squared plus cx. So when I combine my like terms and so forth, I'm going to end up with 2x squared minus x plus 4 equals, well, my x squared pieces are what? A plus b. So a plus b times x squared. That's those two. The x pieces is just plus cx. And the constant part is plus 4a. So this one means what? Again, comparison. A plus b has to be 2. C has to be -1. So because there's just the variable c attached with x, it has to be the same as whatever's in front here, which is a -1. And then 4a has to be equal to 4. So c is done. Here I can divide both sides by 4, so a is equal to 1. And now plug that back into the first one. If a is 1, then that means b is also 1. So again, hopefully, once you get to that point, the solution is the easier of it. It's really getting the thing set up right to start. So now my answer then, now that I have a, b, and c, just plug it back into where you were. So the original 2x squared minus x plus 4 over x times x squared plus 4 is equal to a over x, so 1 over x, plus this guy. Bx, well b is 1, so that's just x, plus c, c is minus 1, so x minus 1 over the x squared plus 4. So that's it for that type of case. Irreducible with a quadratic in the denominator. So that's type 3. Come on back and we'll look at the fourth and final type for our partial fractional decomposition.